Hello, I am Tang Wei from Tsinghua University. I am going to introduce our LibDB, an effective and efficient framework for detecting third-party libraries and binaries. Third-party libraries are important components of modern software systems. Many platforms provide a large number of available libraries. They are reused frequently during software development. However, security issues of the third-party code continue to arise. Vulnerabilities in well-known third-party libraries, such as the Heartbleed, could bring security threats to millions of devices. Existing techniques for third-party library detection in binaries essentially have a similar detection scheme. They adopt two types of basic features including string literals and exported function names. Two sets of features are constructed from a detection target and a library, respectively. The task to detect library reuse is to calculate a similarity score by comparing these two feature sets. Existing works that compare two sets of basic features have the following three limitations. First, some features are popular and included in a large number of libraries that cause low precision when detecting against a large-scale database. Next, some libraries only contain few features because of partial clone, debloating, etc. It leads to low recall when few features exist. Finally, basic features may not change cross-library versions. They are too coarse-grained to identify versions. This figure provides an overview of LibDB. It contains 5 components: feature extractor, basic feature matching, function retrieval, function call graph filter, and version identification. LibDB relies on the two feature databases, namely Basic Feature Database and Function Vector Database, which will be applied in two channels, Basic Feature Channel and Function Vector Channel, during detection. For Basic Feature Channel, we directly adopt the rules and thresholds used in B2S Finder. A candidate is positive when it meets any of the three conditions. Positive units are candidate list A and are sent to the FCG filter as inputs. In the function vector channel, LibDB can retrieve candidates using functions. All functions of detection targets and libraries are extracted and converted to representation vectors using Gemini. For better generalization ability, we train the network model using functions compiled from 120 compilation scenarios. We use Milvus engine to retrieve the top k most similar functions for each function in the detection target and locate corresponding comparison libraries as candidate list B. The candidate list obtained from two channels may contain lots of false positives. In order to filter out them, we propose a novel FCG-based algorithm to compare binaries with the detection target and filter out those with low similarity. As mentioned above, we retrieve similar function pairs through function retrieval module. Subfigure A illustrates the FCG of a detection target where a node represents a function and a directed edge represents function call dependency. Green nodes correspond to functions that exist in the similar function pairs and white nodes correspond to functions that do not exist in similar function pairs. We take the matched nodes, i.e. green nodes, as anchor nodes, since they are key points to show that two graphs are similar. To reduce the size of graphs, we skip unmatched nodes, i.e. white nodes, to build a mini FCG using anchor nodes only. In an FCG, unmatched nodes will be removed and dangling edges are connected from upstream nodes to downstream nodes. The corresponding mini FCG of subfigure A is shown on the left of subfigure B. We remove all white nodes. If a matched node transitively depends on another, for example, node 2 transitively depends on node 3, we add a new edge from node 2 to node 3 in the mini FCG. The original dependency relationships are retained. The mini FCG formed by similar functions in the library is shown on the right of subfigure B2. Mini FCGs are formed by similar functions. It means that nodes are similar. Therefore, we calculate the number of common edges as the similarity score. We compare LibDB with several related methods to evaluate the detection accuracy. From the results in this table, we can see that LibDB outperforms all the baselines in terms of F1 score. Besides, the experimental results demonstrate that our fine-grained function features can effectively improve the performance of version identification in terms of version distance and version precision. We analyze the effectiveness of the function retrieval module in improving the recall when no enough basic features are available. Detection results on data with different proportions of basic features are provided in this table. It shows that our function retrieval module can bring different improvements to all methods. Improvements are more significant when there are fewer basic features. In extreme cases, for binaries without basic features, the function retrieval module can achieve a precision of 96.5% and a recall of 32.2%. We evaluate the effectiveness of FCG filter by adding it to all baselines. As shown in this table, the use of FCG filter can significantly improve the precision of all evaluated approaches and their variants. Meanwhile, the recall rates generally remain the same. Finally, I'd like to make a conclusion. In this paper, first, we propose a novel framework LibDB that utilizes function contents to detect binary TPL reuse instead of relying on basic features only. It embeds functions in such a way that the similar functions have a higher cosine similarity score than the dissimilar functions. We recall more TPL reuses through function retrieval module that increases the recall rate. Next, in order to improve the precision, we design a comparison algorithm based on FCGs to calculate the similarity between two binary files. The algorithm greatly improves the precision of both LibDB and existing approaches. Finally, we use fine-grained function features to better identify the versions of the reused libraries, which is not supported by previous binary TPL detection methods. Extensive experiments have demonstrated the effectiveness and efficiency of LibDB. Thanks for your watching.